The purpose of the Air Data Inertial Reference System ADIRS is to provide air data and inertial information to the EFIS system, the FMGC, and other users.
The A320 has 3 separate, but identical, air data inertial reference units.
Each ADIRS combines an Air Data Reference Computer, or ADR, and a Laser Gyro Inertial Reference System, or IR. The ADR and IR systems of each ADIRS operate independently, and failure of one system will not cause failure of the other. The ADR part receives information from aircraft probes and sensors. The ADR part provides various items of air data to the Flight Management and Guidance Computers, FMGC, and other users. The air data provided includes Mach, airspeed, temperature, overspeed warnings, barometric altitude, and angle of attack. The IR part provides inertial data to the FMGC, EFIS, and other users. The inertial data provided includes track, heading, acceleration, flight path vector, aircraft position, ground speed, and attitude. The 3 ADIRS are controlled through the ADIRS panel, located on the overhead panel. They are initialized through the 2 MCDUs located on the pedestal and by 2 of the switches on the switching panel located at the front of the pedestal. Independent data is supplied by each ADIRS. Let's see an example of this. In the EFIS system, ADIRS 1 supplies the captain's EFIS and ADIRS 2 supplies the first officer's EFIS. ADIRS 3 is available as a backup to either EFIS system via the switching panel.
Now, let's look at the ADIRS Mode Selector Unit, ADIRS MSU.
The panel is divided into 2 parts, the upper section for the IR and the lower section for the ADR. The 3 rotary mode selectors have control over both the IR and the ADR. The controls and indicators for the individual ADIRS are grouped and arranged in the following order: 1, 3, and 2.
Each ADIRS has an associated rotary mode selector. In the off position, the ADIRS is not energized, so ADR and IR data are not available. The 3 ADR and the 3 IR switches normally remain on, but they can be selected off in response to ECAM procedures. In the nav position, the ADIRS is energized. The nav position is the normal mode of operation and full inertial data is provided to the aircraft systems. The on-bat light comes on to inform the crew that the ADIRS system is being powered by aircraft batteries only. The light also comes on for a few seconds at the beginning of a full alignment as a test of the battery circuit. The following items can also be used in case of given failures. The ATT position of the ADIRS selector allows the selection of this IR mode, providing only heading and attitude information in case of loss of navigation capability. The 3 ADR push-button switches normally remain on, but they can be selected off in response to ECAM procedures. When done, it only stops the related ADR part, and not the IR part. The 3 IR push-button switches operate in the same way for the ADR push-button switches. But if an IR fault light is flashing, the related ADIRS selector can be selected to ATT in order to recover the attitude and heading information. The alignment phase is completed when the ADIRS are initialized to an appropriate position. With GPS available, initialization is automatic, using the GPS position, and does not require pilot action. However, automatic initialization may be manually overridden during the alignment phase by accessing to the ADIRS init page. This method will be explained later in the operation module. In case of unreliable airspeed indications, for example after the 3 ADIRS failure, the backup speed and the altitude indication are available on both PFDs, provided the 3 ADIRS have been set to off. The speed scale is replaced by a backup speed scale, bus, based on the aircraft's angle of attack information and on the slat flap configuration from SFCC. The backup altitude scale is based on GPS altitude information. Due to the GPS altitude inaccuracy, the last 2 digits are double-dashed. The vertical speed indication is not available. Note, on the FMA, an amber use man pitch trim is displayed when the landing gear is down. The backup speed scale, bus, behaves like a normal speed scale. High speeds, fast, towards the top, and low speeds, slow, towards the bottom. 2 different images can be displayed. One for clean configuration, and another one for high lift configuration. Refer to the end of the presentation. The scale is divided into 5 colored ranges. A red upper area above Vmax with decreased load margin. An amber and red upper area between Vmax with decreased load margin and Vmax with normal load margin. The green area is in accordance with the normal speed range between VLS and Vmax. An amber and red lower area between VLS and Vstall warning. And a red lower area which indicates the stall speed area. The aircraft's angle of attack speed must remain in the green area. For each configuration, a green bug indicates the target speed, which is the optimum speed that the flight crew must maintain, especially during approach and landing. The target speed is automatically set by the system. The aircraft current speed is indicated by a fixed yellow horizontal bar with a yellow triangle. The backup speed scale is designed for a load factor of 1. Therefore, roll maneuvers must be flown with care. Bus operation, fly the green. The following video is a computer animation showing bus operation for a generic Airbus fly-by-wire aircraft. Note, flight parameters displayed on the video are based on an A380. The goal is to show the bus display through different configurations. The aircraft is flown with the bus displayed on the PFD. Auto thrust is off. Alternate law is in force until landing gear down, then direct law. The ISO speed scale is indicated for information. To start with, the aircraft is stable at target speed. Then, an acceleration is performed in order to reach the high-speed amber-green limit for a short time. The pilot then decelerates towards the low-speed green-amber limit. After a short stabilization, an intermediate approach is carried out, then an ILS approach. Final configuration is Conf 3, landing gear down.
Acceleration. Stabilization. Deceleration. Stabilization. ILS on. Flaps 1. Flaps 2. Gear down. Flaps 3. Final approach.